All right, so this system, again, let's see if there's any of the variables that we can eliminate pretty quickly. I'm looking at the y's again. Actually, the x's would be too, because this coefficient is a -1, and I can easily make that be an opposite with the 5 right there, okay? So that's what I'm going to do, and actually it just kind of makes it different than the last one as well. So on this one, I'm eliminating the x's, okay? And again, it's just really to be different from what we did last time. So I'm going to take the top two equations, and then I'll work with those, and then I'll take the top equation. Again, I'm working with that top one specifically because it has the opposite, and it's a phantom 1 coefficient of x. So I can make it be an opposite to that 5x pretty quick. But I'm going to need a little bit more space, so here we go. So let's start with this set on the left. Okay, so I'm going to take this equation. I'm going to multiply it by 2 so that the coefficients of x will be opposites, right? So that's going to give me -2x plus 4y plus 8z, and that will equal -4. Okay, then we got the other equation. And now I'm ready to add these two together. Now the original intent here, right, because I'm going to add all of these together, the original intent was to eliminate the x's, and we've done that successfully. The problem is that I've eliminated the y's and also the z's, which means on the left side of this equal sign, I really just have 0. I have nothing on the left, just 0. But on the right, you can see that we would have -4 plus 5, which is 1. Okay, now this brings up a question. And it doesn't matter if you have a variable with the 0, by the way. But we have to ask ourselves a question, because the equal sign is a conditional statement. Is it true or is it false? And we can ask ourselves, when is 0 equal to 1? And the answer is never. It's never equal to 1. Okay, so this means that, at least from this, that if you were to graph these, let's say that you were to graph these and you found them to be lines, they would be parallel. Yeah, so essentially we're saying that the graph would show a parallel relationship. Or in other words, the graph never meets. Okay, the lines never meet, if you will. And what this also means for us is that really there's just no solutions. Now, the good news for us at this point is that we don't actually have to solve the other one. That's just as far as we need to go. Now, that's just the relationship of the two equations that we had. It's possible you may find that maybe you could find a new equation by eliminating the x's here, and you could. But that doesn't matter. So these two, you could say they do intersect, but these two right here that we started with, no. So that means, but we need all three of them to meet. And by the way, they're not lines, not that that matters, but all we need to understand is that we have two equations that have a parallel relationship. It doesn't really matter what happens after that. We know that all three of them have to meet, and one of them never will with another one. That's all that matters.